What if everything you see, feel, and experience isn't real? What if the universe itself is just a massive simulation, like a cosmic video game running on an unimaginable computer? What if everything you see is not real? Take a moment. Look around you. You see your room. You see the world outside. You feel the chair you are sitting on. But what if all of it is just an illusion? Imagine a city, full of life, full of people. Now imagine that city is made of digital code. It sounds like science fiction, but even top scientists like Elon Musk and physicist Nick Bostrom have asked, what if we're living inside a simulation, like in The Matrix? In that story, humans live peaceful lives in a world that feels completely real, but in truth their bodies are asleep in pods. Their minds are connected to a giant computer program. This program creates a shared dream, a simulated reality. The film made this idea famous for millions. It showed how a fake world could feel as real as a true one. When we hear about living in a simulation, one image often comes to mind. But this idea is much older than the movies. It made us ask, could this be happening to us? Plato told the allegory of the cave. People chained inside a dark cave. They can only see shadows on the wall. Those shadows are their only reality. Plato asked, what if one was freed? What if they saw the real world outside? In Indian philosophy, Maya describes reality as an illusion, a veil that hides ultimate reality. These are philosophical, not scientific ideas, but they show humanity's long fascination with the question. Today, the question has a modern form. People like Nick Bostrom at Oxford have studied it seriously. They use logic, mathematics, the laws of physics. They're not just telling stories, they're building arguments. They're testing whether the simulation hypothesis is logically possible. What was once for mystics and storytellers has entered the halls of science. Think about the world around you. There are rules. If you drop a pen, it falls down. It never falls up. The sun rises in the east. The sun sets in the west. These are not random events. They follow a strict order, the laws of physics. These laws are incredibly reliable. They let us build bridges that stand. They let airplanes fly. Now, think about a computer program. A program is a set of rules. If this happens, then do that. In a video game, if a player presses the jump button, make the character move up by 10 pixels. Some people see our universe similarly, a system following complex and elegant instructions. The language of these rules is mathematics. Albert Einstein's E = mc squared is a short rule with deep truth. Snowflakes show simple rules creating complex beauty. The parallels are striking. Maybe reality is based on information and calculation, like a program. To simulate an entire universe, you'd need unimaginable computing power. Our most powerful supercomputers can simulate a tiny fraction of the universe for a tiny fraction of a second. It would require a computer the size of a planet, or even a solar system, powered by the energy of stars. Imagine a civilization 1 million or 1 billion years ahead. They might harness black holes or build computers from space-time itself. Does a simulation need to calculate everything at once? Games only render what you see, saving power by calculating what's being observed. Some physicists wonder if our universe works the same way. Perhaps reality is rendered in full detail only when we observe it. This leads to a very strange idea from quantum physics, the observer effect. In quantum mechanics, the rules of our everyday world break down. Things behave in ways that seem impossible. Before you measure it, an electron doesn't have a single position. It exists in a cloud of possibilities, a superposition. Only when you measure, when you look, does it choose a single spot. This observer effect is experimentally verified and deeply mysterious. It's as if the system saves resources, sharp detail when you look, simplified when you don't, like graphics engines in games. Another effect, entanglement. Measure one particle, and you instantly know the other's property, no matter the distance. In a simulation, that's not spooky. The particles are variables in code. Change one. The program updates the other. Distance in the rendered world doesn't matter. The connection is in the code itself. In our universe, nothing can travel faster than the speed of light. It's a fundamental rule discovered by Einstein. This speed is incredibly fast, but finite. It's a hard limit you cannot break. Computers have processing speeds that cap how quickly programs update, like frame rate in video. Smooth motion is really rapid teleporting between frames. Maximum speed depends on how fast the system can update positions. In our universe, c might reflect the smallest distance divided by the smallest time, a computational tick rate. If reality is computation, it must have a clock speed. The speed of light could be its reflection. It's an intriguing way to, think about it. If we accept, just for a moment, that we might be in a simulation, it opens up very big, very deep questions. These are not questions for science alone. They are questions for philosophy. They are questions for religion, for every one of us. Who created it? Who are the programmers? Are they like us but far more advanced? Biological? Artificial intelligences? From a universe before ours? We can only guess. Why create a universe? Perhaps it's a scientific experiment to study galaxies, the origin of life, or the emergence of consciousness, or a historical simulation, ancestor simulators recreating their past. Another possibility is personal. Perhaps the simulation is for experience, not science. What if we are the programmers? Beings who chose to enter, to learn and grow, to experience love, struggle and joy. In this view, we are not helpless characters. We are explorers, here for a purpose we ourselves chose. But there are less comforting possibilities. Entertainment, a movie, or just a subroutine in a larger program. These questions can be unsettling. They touch our deepest needs for meaning and purpose. If we are in a simulation, our creator's motives may be as mysterious to us as ours to an ant. All we can do is live with as much kindness and curiosity as we can. Scientists are seriously considering how we might look for glitches in the matrix. They are designing experiments to try to prove or disprove the simulation hypothesis, moving the idea from philosophy to testable science. One idea: examine the fabric of space and time. If reality is digital, it may be made of tiny discrete units, like pixels, the minimum size, the Planck length. Graininess might affect ultra-high energy particles. Researchers study cosmic rays crossing the cosmos for billions of years. If space-time is a grid, paths may show slight preferences along axes. By mapping arrivals, scientists look for patterns. So far, no clear evidence. Experiments are getting far more precise. Another idea: resource constraints. Complex quantum simulations might show tiny errors. Finding one would be monumental, like spotting a programmer's comment in the universe's source code. So we come to the final and perhaps most important question. What would it mean if we discovered tomorrow that we are living in a simulation? Would everything become meaningless? Would our achievements be worthless? Would our feelings be fake? I do not think so. Our reality, simulated or not, is the only reality we have. Your joy and your sadness are real to you, and that is what matters. Like a great novel, emotions are real even if the world is written. Our experiences and choices are still our own. The love we give, the kindness we show, the knowledge we seek, these have value within our world. Whether the universe is a simulation or not, one thing's certain. We are part of something far greater than ourselves. Maybe we're not players in a game, but explorers of existence itself.